Now the next topic is direction of vector. If vector x and vector y are non-zero vectors of R square or R cube and k belongs to R, then if vector x is equal to ky and k is greater than 0, then x and y have same direction. That is, they are in the same direction. And if k is less than 0, then vector x and vector y have opposite direction. And if x is not a multiple of y, that is x is not is equal to k times y, for k belongs to R, then vector x and vector y have different direction. If direction of vector x and y are same or opposite, then they are called collinear vectors. That is, vector in the same line. That is, they are oppositely in same line or in the same direction in the same line. So this is about the direction of vectors. Now we are going to state theorems which are accepted without proof. So theorem 6.1, non-zero vector vector x and vector y are equal if and only if modulus value vector x and modulus value vector y is equal and vector x and vector y have the same direction. That is, if two vectors are in the same direction and their magnitudes are equal, then these two vectors are said to be equal vectors also. And theorem 6.2 state that if vector x is not equal to 0, then there is a unique unit vector in the direction of vector x. Now, if there is a unique vector in the direction of every vector, now we will find out how can we represent a unit vector in the direction of given vector. So, here we will discuss method to find out the vector, unit vector in the direction of x. So, If vector x is a non-zero vector, then vector x over its magnitude is a unit vector in the direction of vector x, and it is denoted by unit vector x. So unit vector is represented by unit vector is equal to vector over its modulus value. If vector y is equal to k times vector x over modulus x, that is k times unit vector, and if k is greater than 0, then vector y in the same direction of vector x with magnitude k, that is vector y in the direction of x with magnitude k, and if k less than 0, then the vector y is in opposite direction to vector x with magnitude k. So now we will solve example. Find the vector of magnitude 15 opposite to the direction of vector x. So here we have to find vector of magnitude 15, that is vector y, opposite direction of vector x. So for this we have to find the unit vector in the direction of x, that is unit vector x, that is vector over its magnitude, that is under root minus 3 square plus 0 square plus 4 square. So we get minus 304 under root, that is 9 plus 16, that is unit vector minus 304 under root 25, that is minus 304 over 5. So vector y as in opposite direction, so we will take minus k, that is minus 15 magnitude into unit vector. So we get minus 3 into minus 304, that is the vector. So we get k into vector x, that is kx1, ky1 and kz1. So we get this is a required vector which is in opposite direction of the vector x.